Hello, we are dealing with computation of combined process parameters. Today we will see the Markov analysis. The topic of today's presentation is computation of combined process parameters, Markov analysis. We will see Markov analysis with respect to a two-state component, and then we will calculate the unavailability, the unconditional failure and repair intensity, expected number of failures and repairs. Then we will go for three-state Markov analysis. Primarily our material chosen from this book, taken from this book. So, let us now understand what is Markov analysis here and how we are going to use it. So, Markovian process and exponential distribution, they are very much related. So, it is basically the method which deals with the state transitions and then finally, the steady state probability values. And we will consider this diagram what you have already seen. So, we are thinking that the component has two states, one is normal, another one is failed. So, if the component is working, that means it is normal state, it can remain in that state or a transition to the failed state may take place. Now, the transition from normal state to failed state, that will happen based on certain probability values, that will be known as transition probability, like probability that the system will be or the component will be at failed state given that it was at normal. So, we will basically create a small time interval delta t, and then we say suppose at t equal to t, if the component is at normal, and then at x t equal to t plus delta t, the component will be at failed state, then the probability is probability 1 given 0, 1 for your failed state and 0 for working on normal state. Okay. Now, if the component is at failed state, then it will be repaired. So, there will is also a transition probability that the failed component will ultimately repair to as good as new, and that probability is probability 0 given 1. Now, then we will assign some the parameter values, that is lambda and mu, with those probabilities, and we identify all possible states and their probabilities, and then we try to formulate the problem as unavailability analysis problem to find out the how to calculate the unavailability of the component. Okay. So, essentially you know what is lambda t and also you know what is mu t. So, for a very small interval of time delta t, lambda t mu t is nothing but the probability that the component falls during a small interval t and delta t. So, that is why you see that if the component is at working state and then at t equal to t, at what is the probability that it will fail at t equal to x t plus delta t, then this probability is nothing but lambda t dt. So, that is what is written here. At the same time, suppose the component is at failed state, then you also know that this mu t and dt, that is nothing but that component will be repaired during a small interval of time delta t, and it was as good as new at time t equal to 0 and failed at time t. So, then if the transition probability will be mu t dt. Okay. Now, then what will be the probability that the component is working at time t equal to 0 and will also be working at time t plus delta t. So, that is basically probability 0 given 0, that means normal given normal. Normal at time t plus delta t given normal at time t. So, that probability is nothing but 1 minus lambda t dt. The reason you see, when the component is at normal state, it can either remain at normal or it may go to the fail state. So, that is basically two conditions. So, that means if the component transition from normal to failed is lambda dt, and then remaining at normal will be 1 minus lambda dt, because the probability of the two will be 1, and that is also true for fail state case. Now, the same thing, this concept with the use of indicator variable, that means x t is 0, means that component is at normal at time t equal to t, and x t plus delta t equal to 0, that means component is normal at time t plus delta t. So, we can use indicator variable to denote the probabilities. So, then what is lambda t dt? Lambda t dt is this component at time t it is not working, at time t plus delta t it failed. So, then using indicator variable you can write like this, the probability that x t plus delta t equal to 1 given that x t equal to 0. In the same manner you can write down this and this. So, essentially then what are the things we have considered here, you please understand. We have considered that component has two states, one is normal state or failed state. Component change its states with a probability value, that is known as transition probability. And we have already seen that the probability lambda t dt gives a probability, transition probability from normal to failure, and mu 2 dt gives the transition probability from failure to normal. And a component can be either in fail state or normal state. So, as a result, given that the component at time t is at normal and it will remain normal at time t plus delta t, that will be 1 minus lambda t delta t, that is what written here, and in the same way for failure case you can write like this. Okay. So, now with this background, what you want to do, you want to find out that what is the unavailability of a system. Here it is a component, we are basically dealing with the component, but same analogy can be written, can be talked when we discuss the system failure also. So, for the unavailability of a component, we can write down that component, that probability that x t plus delta t equal to 1, that is what we will be interested to find out, probability x t plus delta t equal to 1, that will be the unavailability within this delta t period. Okay. So, now let us see that how we can compute this one. Okay. So, you have seen, in fact, you know that what is your unavailability. Okay. So, unavailability, the probability that the component is in fail state at time t equal to t, given that as it was as good as new when time t equal to 0. Okay. So, q t means what you can write, q t probability x t equal to 1. Now, then we can write q plus delta t equal to probability that x t plus delta t equal to 1. Okay. So, if you see here that at t plus delta t it is unavailable, then what are the what are the ways it can happen? One is that the component is normal, means at x t equal to 0 at time t equal to t, and it has been, the transition has taken place to fail state, or it is basically at fail state at time t equal to t, and t equal to t plus delta t, it remain in the fail state. So, that these are the two things. So, that is what is written here. So, what we have written here, you just see probability x t plus delta t equal to 1 given that x t equal to 0. It was here, then it transition take place. So, it was here, that is the probability x t equal to 0, and it transition takes place x t plus delta t 1. So, this from this to this. Second one is this, at time t equal to t or x t equal to and x t equal to 1, it is in the failed state and it remain failed state. So, that is why probability a x t plus delta t equal to 1 given x t equal to 1 into this. So, these are the basically two probabilities are multiplied and that sum up. You understood, I hope. Okay. So, what we have written then, in order to write, should I repeat this? Let me repeat. What is q t plus delta t? You will say that probability that x t plus delta t equal to 1. So, what are the different way it can take place? First one is it is as 0, that is p x t equal to 0, that is, and at x t plus 1 t plus delta t, this is 1 given that at x t it equal to 0. So, this is the first part. Similarly, you can write the second part. So, these two, this probability times this probability plus this probability, this probability. Okay. This is what is the unavailability at time x t plus delta t. So, now what happened? You just put these values like this value as well as this value as well as this value. Now, question is what is the probability, the transition probability from normal to fails, lambda t dt. Okay. Then what is the probability x t equal to 0? It is basically probability that it is available, component is available at t equal at basically t equal to t. So, that means it is 1 minus unavailability. So, you have written 1 minus unavailability, 1 minus q t. Then, so this one is lambda dt, this one is 1 minus q t. Then what will happen to this? X t 1 given that it was 1 is 1 minus, this is 1 minus mu dt. What will be the multiplication? It is failed q t. So, that is what is written here, 1 minus mu t. So, we can do some algebraic manipulation here. So, q t plus delta t you write, from this side you bring q t, because this into this is q t, bring this, and this side you write this dt is there as well as dt is there, dt will be here. Now, dt, then here dt into 1, that is lambda, and here basically the dt into mu. So, lambda minus mu into q t and plus lambda dt, you just see. So, if you are not understanding, I am writing this one, this will be lambda dt minus lambda dt q t plus q t minus mu dt q t. So, what you have done there? This minus this written there. Then you see dt lambda is there and okay, dt lambda t q t is there, mu t lambda t q t is there. So, minus and minus. So, minus mu lambda minus mu dt dt and q t, then 1 lambda dt is here. Okay. So, now the q this minus this, if you divide this one by dt, you will get this equation. What is this? The in between what is there? So, this can be written as q t plus delta t minus q t by dt equal to this much. So, lambda plus minus lambda minus mu q t. So, now this quantity is nothing but del q t by d t. So, that is what is written here. So, del q t by d t equal to this plus this. This is the first order differential equation. So, you have to solve this equation, and if once you solve this, we will see the Bernoulli formula, that once you solve this, given this condition t equal to 0, unavailability is 0, the solution to this differential equation will be this q t equal to lambda by lambda plus mu 1 minus e to the power minus lambda plus mu into t. Okay. So, this is our unavailability and for two state system using Markov analysis. Okay. So, the failure rate, all those things, failure rate is constant and ultimately that failure density, exponential failure probability distribution. Okay. Now, we will show you that how to arrive at this solution from given this differential equation. Okay. This is the equation, Bernoulli form of differential equation. First order del y by del t r t y s t y to the power n. If your differential equation of is this form, then the solution to this equation will be of this form, where I t is this e to the power integration 1 minus n r t d t. Okay. So, now we have to see that our equation, this equation, whether it is this form or not. So, first you do one thing, that if I say that y is q t, then del y by del t is basically del q by. So, del y by del t equal to del q t by d t. Okay. Now, if we say r t equal to lambda plus mu, if we say r t equal to lambda plus mu and y equal to q t, already y equal to q t, then this into this is nothing but this quantity. So, when this quantity is r t into y, and this quantity is dy by dt plus equal to lambda. What is we are getting here? S t y t to y to the power n. Now, if we put n equal to 0, then what will be this side? S t. So, S t equal to lambda. Now, if we say S t equal to lambda. So, that means for n equal to 0, this equation is actually this equation satisfying this. Once this equation satisfying this, we can use the solution. This is the solution. So, that is what you are writing here. So, our I t is e to the power 1 minus n. So, I t I can write e to the power integration 1 minus n r t dt, n equal to 0. So, that means e to the power integration 1 minus 0 is 1. What is our r t? R t is lambda plus mu into dt. So, I t you got it. So, you know I t, then our solution n equal to 0. So, y equal to q t equal to 1 by this I t into 1 minus n is 1. So, I t you write I t as it is, S t is what? S t is lambda. So, S t lambda dt plus c. So, now you take the integration, first integration of this and then also integration of this, and when you put these two, ultimately you will be getting, suppose integration of this okay, same thing. Now, you will be getting this equation. Okay. So, lambda by lambda plus mu into your lambda by lambda into c into e to the power minus lambda mu t. Now, at initial condition, if you put t equal to 0, qt equal to 0. So, when this becomes 0, so then here t is 0, e to the power 0 is 1. So, c will be minus this, c will be minus this. How? This side 0 equal to lambda by lambda plus mu plus c into e to the power 0 means 1. So, c will be minus lambda by lambda plus mu. So, you got c equal to lambda plus minus lambda by lambda plus mu, and if you put in this equation the c part, you will be getting this. Okay. So, lambda by 1 minus lambda into 1 minus e to the power minus lambda mu into t. So, this is the equation we have obtained using Markov analysis, and this is our unavailability equation. So, if you know unavailability equation, and we have seen in the last class that how this unavailability is related with unconditional failure intensity and unconditional repair intensity, last class you recall. So, we have written there that W t is unconditional failure intensity, which is lambda into availability. Now, availability 1 minus q t. So, already we have identified the value of q t. So, you put here the value of q t, and finally, you are getting this is your unavailability equation, unconditional failure intensity equation. Okay. So, q t is what? Q t we got lambda by lambda plus mu e to the power into 1 minus e to the power minus lambda plus mu into t. Then W t is this. Again the repair 1, the unconditional repair intensity, you will be writing like this. Okay. So, earlier I said that these are all intensity. So, you write intensity. So, unconditional repair intensity is mu into this. Now, mu is known, q t is known. So, this is your equation. So, you can calculate expected number of failures. Once you have unavailability, you are getting W t. So, once you have small W t, then that expected number of failure, this 0 to t time, you just integrate W t dt 0 to t, this integration will give you this equation, and expected number of repair will give you this equation. Okay. Please try, and I am sure that you will be able to do it. This is very straightforward case. So, only that Markov state transition you have to understand, and in case of two state you will be having 0 and 1, you use the indicator variables, and also you know that what are the probability once the lambda, the parameter for failure and repair processes are given. So, using Markov analysis, so you will be able to find out the q t, and from q t other parameters of the component will be estimated, including W t, capital W t, like this. Means your unconditional failure intensity, expected number of failures, unconditional failure repair intensity, and expected number of repairs, and also if you want that mean time and other things also you will be able to calculate. Okay. Now, let us see another example where we are basically thinking that the component is not is 2 state one component, it is a 3 state component. What do you mean by 3 state component? We are saying, so I am writing here component, here also component, here also component. Okay. Just I will go back little. Okay. So, here we have written in terms of component, no problem. So, here also I am writing in terms of component. Okay. Now, that means how many states are there? 0. So, 0, state 1 is 0 normal, then 1 it failed, but failed safely, and 2 mean failed unsafely. Okay. So, you have heard the concept called fail safe system. The component may be fail safe. So, it fail, but it will not create any problem to the neighboring component or the system as a whole. But if it fail and ultimately it leads to loss apart from the component loss itself. So, that means or it will create problem neighboring component or the system as a whole. So, then what will happen? It is basically we are saying that it is unsafely. So, here also you can find out the transition probabilities and you can create the equations for availability or as well as unavailability. Okay. Now, suppose the component is at state 1 and that means and it is repaired and the repair intensity, that is the parameter mu s. So, then a repair rate basically mu s is basically that the parameter value and per unit time, the probability failure per unit time. So, then if you multiply it by dt, then what will happen? That means, if the system is at fail state, what is the probability that it will be in the working state is mu s dt. Suppose it is working, but what is the probability it will transit to your fail state, then lambda s dt. Similarly, suppose it is working, but it can go to the unsafe totally lambda u dt and it will be repaired back to normal, it is mu u dt, mu for repair probability and lambda for that is which is a failure probability, obviously per unit time, probability per unit time. Then if you are interested to know that what is the availability of the system at time t plus delta t, x t plus delta t, then this indicator value will be 0. This is basically availability. That means, the probability at t will at the system will be at component will be at 0 state at time t plus delta t. So, how many ways it can happen? It can happen first if it is at the state 1 and it is a transition takes place to state 0. It is at state 0, remain at state 0. It was at state 2 and transition has taken to state 0. This is what is written here. First, it is a state 1, that means probability x t equal to 1. So, the transition takes place within delta t time. So, that is basically this. So, these two multiplication talks about that the component at state 1 at time t equal to t and its state 0 at time t equal to t plus delta t, then this is the probability. Similarly, it is at state 0 this and it remains in this. Similarly, it is state 2 this, remain at state 2 this. So, these three terms will be added, probability term related to staying at state 1 and transition to state 0, staying at state 0 and remaining to at state 0, staying at state 2 and transition to state 0. So, this. Now, if you basically now algebraic manipulation if you do, you will be getting. So, what you will do? You will put the values basically. So, P 0 t plus delta t. Now, what is if it is at state 1 coming back to state 0, that means mu s into delta t. So, dekho we have written mu s delta t. Then it was in state 1, that is P 1 t. So, in this, and the second one is will be what is it is at state, it was at state 0, that is P 0 t, and it remains at this. Then there are 3 states. So, this probability plus this probability and plus this probability will be equal to 1. So, as a result it will remain at state 0 probability is 1 minus lambda u dt and lambda s dt. So, that is written here. Okay. Now, you understand. So, do algebraic manipulation here and finally, you will come to this equation. Okay. So, del P 0 by del t plus lambda s dt delta u dt P 0 t equal to mu s P 1 t mu u P 2 t. Now, what is mu s? Mu s is this, means it failed safely and it is repaired. What is the probability of repair? Similarly, it remain and failed unsafely, then this is probability. It is working, going to state 1, going to state 2. Okay. Now, what do you require? You have to solve this, but in order to solve this, you require to know P 1 and P 2 also. So, what you have to do? You have to find out these two also. So, in the same analogy, the way we have found out P 0 t plus delta t, you will be able to find out P 1 t plus delta t. So, P 1 t plus delta t means it is in state 1, then this is nothing but that it is in the state 0, transition takes place to state 1 into that it was in state 0 plus it was in state 1 remain in state 1. There is nothing related to, we have not considered anything related to the transition from fail safe to unfail unsafe or fail unsafe to fail safe. This is not possible under the given condition, it is not possible. So, there is no other transition apart from transition related from 0 to 1 or remain at 1. Similarly, here 0 to 2 or remain at 2. There is no state transition from 1 to 2 or 2 to 1. So, as a result, when we are computing the system that unavailability at or system is at state 1, then what we are doing? Then we are writing that the possibilities outcomes are like this. Okay. So, first one is this, second one is this, then algebraic manipulation, you got this equation, and for the other case P t plus delta dt, this one here also two possible scenarios. So, their probabilities are every scenario probability is computed, these two are summed up to get this, and then through algebraic manipulation again we got this equation. So, you have 3 differential equations, this P 0, P 1 and P 2. Here we have used straightway using P 0, P 1 and P 2. So, 0 for normal state, 1 for fail safe state and another 2 for fail unsafe state. Now, when we put boundary condition and use the that proper solution approach, what happened? We will get P 0 is this, P 1 is this, P 2 is this. So, that means what happened? P 0 means it is the system availability, P 1 unavailability because it failed safely, P 2 unavailability failed unsafely. Okay. So, the situation may be 4 state, may be n state situation, and you can use that Markov chain or Markov analysis to find out the that different scenarios, different probability parameters for components under consideration. I hope that you have understood it, and we have taken the 3 state case example from this book and 2 state one from this book, and overall the Markov chain analysis or Markov analysis as such, this some portion is given in this book, but for the solution approach you may refer to some differential equation book. Okay. Thank you very much.